Hello students, welcome to e-learning class. Standard 9th, Mathematics Part 1, Chapter 2, Real Numbers. Let's study. In this video, we will learn about similar or like surds. Root 2, minus 3 root 2, 4 upon 5 root 2 are some like surds. If P and Q are rational numbers, then P root A and Q root A are called like surds. Two surds are said to be like surds if their order is equal and radicands are equal. See, here the radicand is A, the radicand is A. And the order of the surd is 2. Order of the surd is 2. Order and radicand are same. Therefore, these are like surds. For simple, if this is the rational part and this is the irrational part. This is the rational part and this is the irrational part. If the irrational part is same, then you can say that the surds are similar or like surds. Root 45 and root 80 are surds of order 2. So their order is equal, but the radicands are not same. Here the radicands are not same, but the order is 2. Are these like surds? Let us simplify it as follows. Root 45 is equal to root 9 into 5 is equal to root 9 into root 5 is equal to 3 root 5. We have simplified root 45 as 3 root 5. Root 80 is equal to root 16 into 5 is equal to root 16 into root 5 is equal to 4 root 5. Means root 80 is simplified as 4 root 5. Then observe the irrational part of this surds. Here the irrational part is root 5. Here the irrational part is root 5. Therefore, 3 root 5 and 4 root 5 are now similar or like surds because the irrational part is same. Means root 45 and root 80 are similar surds. Our next topic is comparison of surds. We will study this with the help of some examples. First example, 6 root 2 and 5 root 5. While comparison of the surds, the outside part should be taken in the square root. Therefore, this 6 can be taken in the square root as root 36 and this 5 is taken in the square root as root 25. Therefore, root 36 into root 2 and root 25 into root 5. 36 into 2 is 72 and 25 into 5 is 125. Therefore, root 72 and root 125. Now compare the radicands. 72 and 125. 72 is less than 125. Therefore, 6 root 2 is less than 5 root 5. In this way, you can compare the given surds. See the second example. 8 root 3 and root 192. Here, root 192, the whole number is in the square root. But you have to take this 8 in the square root. Therefore, root 64 into root 3 and root 192. Now 64 into 3 is 192. Therefore, root 192 and root 192. See the radicand here. Here the radicand is 192, radicand is 192. Both are same. Therefore, 192 is equal to 192. Their square root are also equal. Root 192 is equal to root 192. Therefore, 8 root 3 is equal to root 192. See the third example. 7 root 3 and 5 root 3. You have to take this 7 in the square root, this 5 in the square root. Therefore, root 49 into root 2 and root 25 into root 3. 49 into 2 is 98, 25 into 3 is 75. Therefore, root 98 and root 75. See the radicand here. 98 is greater than 75. Therefore, 7 root 2 is greater than 5 root 3. In this way, you can compare the given surds. The next topic is operation on like surds. If the surds are like surds, then you can add it, subtract it, multiply it, and divide it. We will see some examples. Example 1. Simplify 7 root 3 plus 29 root 3. Here, these are the like surds because the irrational part root 3 and root 3 is same. Solution. 7 root 3 plus 29 root 3 is equal to 7 plus 29 root 3. From both these surds, root 3 is common. Therefore, it is taken outside the bracket. Therefore, 7 plus 29 is 36. Therefore, 36 root 3. In this way, you can add the given surds. Second example, simplify 7 root 3 minus 29 root 3. Now, we will subtract this surd. Solution. 7 root 3 minus 29 root 3 is equal to 7 minus 29 root 3. The root 3 part is same, which is taken outside the bracket. 7 minus 29 is minus 22. Therefore, minus 22 root 3. In this way, you can subtract the like surds. We will see the third example. Simplify 13 root 8 plus 1 half root 8 minus 5 root 8. If we observe the example, here the irrational part means root 8, root 8, root 8 is same. Therefore, these are like surds. Solution. 13 root 8 plus 1 half root 8 minus 5 root 8 is equal to this irrational part taken outside 13 plus 1 half minus 5 root 8. Now add these numbers and subtract these numbers, means first addition and then subtraction. Here in the denominator there is 1, here the denominator there is 1, here in the denominator there is 2. Therefore multiply this numerator by 2. Multiplying this here 2, we will get 26. Multiplying here by 2, we will get minus 10. In this way, 26 plus 1 minus 10 upon 2 root 8. 26 plus 1 is 27 and 27 minus 10 is 17. Therefore, we get 17 upon 2 root 8. Now, this root 8 can be written as 17 upon 2 root 4 into 2. And 2 can be taken up. 4 can be, means square root of 4 is 2. Therefore, 17 upon 2 into 2 root 2. Here, these 2 and these 2 get cancelled is equal to 17 root 2. This is the simplification of the given surds. The next topic is rationalization of surds. If the product of two surds is a rational number, each surd is called a rationalizing factor of the other surds. Example 1. If surd root 2 is simplified by root 2, we get root 2 into 2 is equal to root 4 and root 4 is equal to 2 is a rational number. Therefore, root 2 is a rationalizing factor of root 2. Because when you multiply this root 2 by this root 2, you get 2, which is the rational number. Therefore, these are the rationalizing factor of each other. Example 2. Multiply root 2 and root 8. Root 2 into root 8 is equal to root 16 is equal to 4 is a rational number. Therefore, root 2 is the rationalizing factor of root 8. Here, this root 2 is the rationalizing factor of root 8 because after multiplication we get a rational number. After multiplying the two surds, if we get the rational number, then the number is called the rationalizing factor of the other. Similarly, root 8 root 2 is also the rationalizing factor of root 2 because root 2 into 8 root 2 is equal to 8 root 2 into root 2 is equal to 8 into 2 is equal to 16. In this way, after multiplication of the two surds, if we get the rational number, then the surds are called the rationalizing factor of each other. Now we will see some examples on rationalization. Example, find the rationalizing factor of root 27. Solution, root 27 is equal to root 9 into 3 is equal to 3 root 3. First, we have simplified this root 27 into 3 root 3. Therefore, 3 root 3 into root 3 is equal to 3 into 3 is equal to 9 is a rational number. In this way, root 3 is the rationalizing factor of root 27. Note that root 27 is equal to 3 root 3 means 3 root 3 into 3 root 3 is equal to 9 into 3 is equal to 27. Hence, 3 root 3 is also the rationalizing factor of root 27. In the same way, 4 root 3, 7 root 3 are also the rationalizing factor of root 27. Out of this, root 3 is the simplest rationalizing factor. You have to see the smallest rationalizing factor of that number. Okay, all these are rationalizing factor of root 27. But the simplest is root 3. Therefore, root 3 is the rationalizing factor of root 27. Because after multiplication, you get the rational number. In rationalization, we will see the rationalization of the denominator. Example, rationalize the denominator of 1 upon root 5. Solution, 1 upon root 5 is equal to 1 upon root 5 into root 5 upon root 5 is equal to root 5 upon 5 because root 5 into root 5 is 5. Multiply numerator and denominator by root 5 because after multiplication to the numerator and denominator, you can solve it. Here, the denominator is rational number. This is known as the rationalization of the denominator. In the denominator only, you have to bring the rational number by multiplying a particular number. The second example is rationalize the denominator of 3 upon 2 root 7. Solution, 3 upon 2 root 7 is equal to 3 upon 2 root 7 into root 7 upon root 7 is equal to this multiplication of the numerator is 3 root 7 and the multiplication of the denominator is 2 into 7 is equal to 3 root 7 upon 14. Here we have brought it the rational number. Therefore, this method is known as rationalization of the denominator. Now, homework on these topics. Classify the given pair of surds into like surds and unlike surds. You have to classify all these surds into like surds and unlike surds. First of all, you have to simplify it. Okay, by factorization, you have to simplify it. Means simple surds convert into simple surds and then compare the radicand. Okay, and if the radicand is same and the order is 2 here, order is same, and if the radicand is same, then you can say that these are like surds, otherwise the given surds are unlike surds. Second example is simplify the following surds. You have to simplify it by factorization. after factorization, you can take the number which have the perfect square. They can be taken out. Okay, and in this way you have to simplify the given surds.